So today we're going to go through our third day of sixth grade review. We're going to finish up weather, talk about matter, and start with some more about water. So we're going to start by finishing up just a little bit of weather from yesterday. So if you look at your notes, there's a few definitions here. The first one is thunderstorms. Thunderstorms are formed where the land is strongly heated. They can bring rain and hail to an area. So thunderstorms are where land is strongly heated. The second one is that hurricanes form over warm tropical water and are fed by the energy of that water. And they usually start off the coast of Africa and travel west in the Atlantic Ocean. So whenever we're thinking of hurricanes, make sure you realize that it's warm tropical water, and they are usually from Africa traveling west to the Atlantic Ocean. Tornadoes are strong storms that form over land that develop winds of high speed, causing destruction in its path. So tornadoes have winds of high speed. Sleet is a type of precipitation that falls from the sky and freezes upon contact with a colder surface. So sleet is liquid in the sky and it freezes when it contacts something cold. Freezing rain is precipitation that falls from the sky and hits the ground already as ice. And then a last one, just as a side note, forest fires and volcanic eruptions are also two other natural processes that can affect the environment. All right, so next we're going to move into matter. So we're going to talk about matter. Matter is anything that takes up space and has mass. So matter is almost anything that we can talk about. There are three different states of matter, and we've talked about them a lot this year. They're solid, liquid, and gas. And matter is made up of lots of smaller things that are called atoms or molecules. And here's a picture of our solid, liquid, and gas molecules or atoms. Now, what is formed when two elements mix together but do not chemically bond? So we went over this some this year as well. A mixture is something that is combined but not chemically formed. So coffee is made from coffee grounds and hot water. And so this is asking what the solvent is and what the solute is. So the solvent is what is actually doing the dissolving, and the solute is the part that is being dissolved into something. So in this case, water is the solvent and coffee grounds is the solute. And then what's the universal solvent? So water is actually called the universal solvent. More substances dissolve in water than dissolve in anything else on the planet. And water actually dissolves lots of different things, and most of the water on the planet has minerals and things dissolved in it. So we call it the universal solvent. Now, Earth's atmosphere is made up of two main elements. The first one is nitrogen, which is 78%, and the second one is oxygen, 21%. All right, moving into the periodic table. For iron, the atomic number is 26. That means that it has 26 protons and 26 electrons. If you remember, our atomic number always tells us the number of protons. Atomic number and protons are always equal. And then protons and electrons are equal anytime we have a neutral atom. All right, so we're talking about protons and electrons. So now we're going to name all of the subatomic particles and their charges. So we have our protons, which are positive, our neutrons, which are neutral, and our electrons, which are negative. And I have a picture here. Protons and neutrons are in the nucleus, and then our negative electrons are outside of the nucleus. Okay, so the ability to rust, what kind of property is that? That is actually a chemical property. If you remember, physical properties are descriptive. They don't change what the object is, they just tell about it. Chemical properties tell you what kind of change could it go under. So it's usually an ability to do something. All right, and then tearing a piece of paper is a type of change, not a property, and that is going to be a physical change. And if you remember, physical changes are the ones that don't produce new substances. They're the same before and after. Chemical changes actually create an entirely new compound or new substance after the change. All right, so next we have a picture of our periodic table square, and it wants you to label each of the pieces. So first, the number 6, that's our atomic number. Remember, that tells us how many protons it has. That is unique to every single element. And that number 6 is also what order the periodic table goes in. Next, our capital C is our atomic symbol or our element symbol. That is going to be one capital letter or a capital letter with a lowercase letter. The word carbon is actually our element name, and that is unique to each element. And then lastly down here, our number 12 is our atomic mass or our mass number. And if you remember, atomic mass is usually a decimal number. That's the average of all the different isotopes of an atom. And the mass number is just the mass of that particular atom. So that's going to be our protons plus our neutrons to make up that mass number. All right, so next, what is the chemical formula for water? Most of us know that it is H2O, but here's some pictures of our oxygen connected to our 2 hydrogens. In CO2, the number 2 tells us that there are 2 atoms of oxygen, and there's another picture for you. All right, so here we've got a balanced chemical equation that you're going to use for a few questions. The first one asks, what are the reactants? So if you look at our picture, it's got our reactants being all of the different pieces that we use to build hamburgers, and then our products are the actual hamburgers that we put together. So in our balanced equation, our reactants would be SNO3 and H2, the things that are on the left side of the arrow. Using the same picture, we can figure out our products. They're going to be our ending materials, or SN and H2O. All right, how many hydrogen atoms are there? So using our equation, we would find that there are 6 hydrogen atoms on the left, 3 in H2, so 3 times 2 is 6, and then 6 on the right, 3 times 2 H's in our H2O. All right, what is the definition of a coefficient? So we've got our picture up there that's got a label on it, but a coefficient is a large number in front of a compound, and it signifies how many molecules of the compound are present. And what number is it in this chemical equation? So in this equation, we've got a 3 in front of our H2 that is our coefficient, and a 3 in front of the H2O. All right, and then the subscript is also labeled in our picture up top there. That is our small number, and it tells us how many atoms of an element, the one that's directly before it, are in a chemical equation. The next question asks, is H2 a molecule or an element, and why? And the answer to this is that it's both. It is an element because there is only one type of element. So since there's only hydrogen, it does count as an element, even though there's 2 of them. And it's also a molecule because there is more than one atom bonded together. So 2 atoms or more bonded together makes a molecule. All right, so how many atoms of carbon are in C9H8O4? And for that, we're just going to use the subscript. That'd be 9 atoms of carbon. And name the elements in the following compound, H2SO4, that's sulfuric acid. That you would just use your periodic table, hydrogen, sulfur, and oxygen. All right, the next question, what are the 4 most abundant elements found in Earth's crusts, oceans, living matter, and the atmosphere? This one's a little bit tricky because each of those things have a very different makeup. But if you look at all of the different graphs that I've included, the 4 most abundant elements are going to be nitrogen, oxygen, hydrogen, and carbon. All right, so the name of the formula CO, that's capital C, capital O, is carbon monoxide. And the name of the element, capital C, lowercase o, that's an element, that is cobalt. All right, so we're going to look at the maximum number of electrons in these shells, or energy levels. And so we talked about these when we did Bohr models this year, and we looked at all of our atomic theory. The first energy level, or energy shell, can hold 2 electrons. The second energy shell can hold 8 electrons. The third energy shell can hold 8 electrons. Now, we went through this a little bit with you in class. The third energy level can actually hold 18, but that has to do with those transition metals and the fact that the electrons in those transition metals hold a little bit different places than they do in the rest of the periodic table. So if you remember 2, 8, and 8, that's going to be the best case scenario. But really remember, the valence electrons are going to be equal to that column on the periodic table. Whatever column it's in is your valence electrons or your outer shell electrons. All right, how many letters does a chemical symbol of an element have? A chemical symbol of an element has one capital letter. Every element has a capital letter, and then sometimes has a lowercase letter. So things like carbon is just one capital C. Things like cobalt, capital C, and a lowercase o. And then 27 just has some definitions for you to copy down. Right? An element is a pure substance that cannot be broken down into other substances by chemical or physical means. So an element is the most basic of that substance. Atomic number, we've already looked at a couple times, but atomic number is the number of protons in the nucleus of an atom, and that's that big main number on the periodic table. Atomic nucleus, that's just the nucleus. That is going to be the central core of the atom that has the protons and the neutrons, and that is where all of the mass of the nucleus is. Remember, electrons weigh next to nothing compared to the rest of the atom, so the nucleus has the mass of the atom. The atomic mass, that is that number on the periodic table, that is the average mass of all the isotopes of an element, so it's usually a decimal number. And the periodic table, we've been using this all year. It is an arrangement of the elements showing the repeating pattern of their properties. When the positive hydrogen is attracted to the negative oxygen in a water molecule, this is called a hydrogen bond. So we've got some pictures here. The first one is the same picture that I showed when we put up just the chemical formula of water. Right, water is an oxygen connected to two hydrogen atoms. The second one actually has the positive and negative sides labeled. In a water molecule, the oxygen is way more negative than the hydrogen atoms. And because of that, the entire water molecule has one side of it that is partially positive and one side of it that is partially negative. And so it's almost like a magnet. It has a positive side and a negative side. And so whenever water is in a cup, whenever water exists really anywhere, it attracts its positive sides to its negative sides, and so on and so forth. And it forms something called a hydrogen bond because the positive parts of water are attracted to the negative parts of water. And that's what keeps water as a liquid at room temperature, because it's holding itself together with those hydrogen bonds. Now, when water vapor and air goes from a gas to a liquid, so if it goes from the gas to a liquid, that's called condensation. When water boils and changes from a liquid to a gas, that's heating up, that's called vaporization or boiling. And then when ice turns from a solid to a liquid, that is our melting process. So taking the solid and melting to a liquid. All right, so next we're going to look at matter and its shape and volume. We've talked about that some this year. We reviewed it. But matter with a shape and a volume that doesn't change is our solid. That's definite shape, definite volume. Matter that changes shape but doesn't change volume is going to be our liquid. All right, volume stays the same. A 2 liter of Coke is a 2 liter of Coke, whether you pour it on the floor or not. Matter that changes shape and volume, so it doesn't have a definite shape or volume, is a gas. What is the force that holds atoms together called? All right, that's going to be our bonds or our bonding. And there are lots of different types. Remember the different ones we talked about, ionic, covalent. What is the basic unit of matter? That's an atom, and that's something that we've talked about plenty. 2 or more atoms of the same element that are chemically bonded together are an elemental molecule or just a molecule, just like our H2. 2 or more elements chemically bonded is a compound. So if they're different elements, then that's a compound, like CO2, H2O, any of those are going to be compounds. All right, matter made up of only one type of atom is an element, and then everything in the universe is made up of atoms. All right, and if you've not heard this joke before, there it is. Never trust an atom. They make up everything. 41, when a substance changes into a new substance. So we use the word substance a lot to talk about either an element or a compound, something that can't be broken down. But when a substance changes into a new substance, so a new element, a new compound, that is a chemical change. All right, and then lastly for today, we're going to go over some preview of water stuff. We're going to talk a lot more about water tomorrow, but there are some important terms that are not in your notes. They're not in your packet, but I want you to add them somewhere on those pages because you need to have these definitions somewhere. All right, the first one is adhesion. We talked about this with one warm-up, I think, but it is the attraction of molecules of one kind for molecules of a different kind. And it can be quite strong for water, especially with other molecules bearing positive or negative charges. All right, so super long definition that basically means water sticks to other surfaces a whole lot. We talked about how water has that positive and negative side. It acts like a magnet. It also sticks to other things as well. All right, so capillary action is something that we talk about when we talk about adhesion. It is when adhesion enables water to climb upwards through thin glass tubes, and there are tubes called capillary tubes placed in a beaker of water. This is also what happens inside of inside of a graduated cylinder. This is what causes the meniscus. It happens in test tubes. It happens in any kind of container. So another term is cohesion, and that's also an important one for tomorrow. Cohesion is the attraction of molecules for other molecules of the same kind. And water molecules have really strong cohesive forces thanks to those hydrogen bonds. So we talked about those hydrogen bonds act almost like magnets. They've got the positive and the negative sides. It would be as if you put a whole bunch of magnets in your cup. The water molecules are holding each other together. And cohesive forces are what is responsible for surface tension. So anytime we have surface tension, which is the tendency of a liquid surface to resist rupture or to resist change, that is because of cohesion. So the reason that a spider can sit on top of the water is because the water is all sticking together. The water's holding on to each other, all the water molecules. So the spider can kind of hang out on top. The water molecules aren't splitting or separating for the spider to fall through.